Good morning, class. Can you hear me? Am I audible? If not, please inform me, okay? Alright. So, before we start, please settle yourselves for the prayer. Miss Candice, kindly lead. In the name of the Father, of the Son, of the Holy Spirit. Amen. So, again, good morning, class. How are you today? Oh, it's good to hear that you are all doing good. So, who's absent this morning? No one? Wow, it's good. It's nice that you are all active in my class. So, for that, I will give you all 10 points for the perfect attendance. So, are you ready for our new lesson? You are all ready. But before that, please click the raising hand button if you have any queries or questions, okay? Did you understand, class? Alright, so before we proceed to our discussion, who can remember or recall our lesson last meeting? Anyone? Okay, do not answer in chorus. Yes, Jadon? Alright, very good. It seems that you really listened to our discussion last meeting. So, as what Jadon said, our topic last meeting is all about mathematical induction. So, who can define what mathematical induction is? Anyone? Oh, it's Jadon again, raising his hand. Yes, Jadon? Alright, very good. Let's give Jadon a barangay clap. So, this time, I will group you into two groups. So, last names that starts with letter A to letter M are group 1. Then, last names that starts with letter N to Z are group 2. So, each group should have a one representative that will be the one to type or send the answer in call messages of the Google meeting. If what group that sends the correct answer first will get the points. Okay? So, who is the representative of group 1? Okay, it's Kisel. So, how about group 2? Okay, Sila is the representative. So, ready? Okay, so let's start. Okay, for number, solve the following. Number 1, 65 divides 5. Okay, group 1 got the answer first. It's 13. So, group 1 have 1 point already. So, number 2, 180 divided by 7. Okay, group 2 got the correct answer first. 25, remainder 5. So, number 3, 250 divided by 10. Okay, it's Sila. The correct answer is 25. Okay, number 4, 67 divided by 2. Kisel got the correct answer first. 33, remainder 1. So, group 1 and group 2 got 2 points both. Okay, number 5, 42 divided by 7. Okay, group 1 got the correct answer first. So, it's 6. So group 1 got 3 points and group 2 got 2 points. Then the points multiplied by 5. So all in all, group 1 got 15 points and 10 points for group 2. So have you learned something from our activity class? Alright. So how did you find the activity? Yes, Miss Sayla? Yes, by simply divide the divisor from the dividend. It's quite easy, right? Yes, so how do you do you have any idea about our lesson for this morning? Yes, Mr. Glenn? Maybe? Another one? Yes, Mr. Shamir? Okay, exactly. This morning we will discuss about divisibility. So, let me read to you first the objectives. So, at the end of the lesson, the students should be able to first, define divisibility. Second, define division algorithm. Third, solve some examples on properties of divisibility and division algorithm. And lastly, demonstrate the understanding of the importance of divisibility in real-world situations. So, this time we will have again a group activity. The same group in the previous activity. So, let's test how far you have learned. Are you excited? Are you ready, class? Okay, here it goes. So, group activity. Okay, for group 1, prove the division theorem 1. Let A, B, and C positive integers where A is not equal to 0. Then, first, we have if A divides B and A divides C, then A divides the sum of A plus B. Then second, if A divides B, then A divides BC for all integers C. Then lastly, if A divides B and B divides C, then A divides C. Okay, do you get it, group 1? Okay, so for group 2, prove the division algorithm, theorem 2. So let A be an integer and D a positive integer. Then there are unique integer Q and R with a 0 is less than or not equal to R, less than D, such that A is equals to DQ plus R. So, you get it, group 2? Okay, so I will give you 10 minutes to do the activity. So, your 10 minutes starts now. Okay? 6 minutes. 4 minutes. 2 minutes left. 30 seconds. Okay, time is up. So this time, choose your representative or reporter to present your output. Another representative, okay? So group 1, present now your output. Okay, very good. Thank you, group 1. So next, group 2. Alright, thank you, group 2. So, we will see if your work or presentation will coincide the explanation or discussion later. So, I will ask you a question. So, what is divisibility? Any idea? Do you have any idea about what is divisibility? Yes, Miss Jasril? Okay. By using the operation of division. Okay. Thank you. Another? None? So, what is division algorithm? Do you have any idea? None? So, let's discuss later. So, do you have any idea and about what are the properties of divisibility and theorems of division algorithm? Okay, so let's discuss about what is divisibility, division algorithm, properties of divisibility and theorems of division algorithm. So, divisibility is one of the most fundamental concepts in number theory. A precise definition of what it means for a number to be divisible by another number is essential for defining other number theoretic concepts such as that prime numbers. So, we'll define division. When one integer is divided by a second non-zero integer, the quotient may or may not be an integer. For example, 12 divided by 3 is 4. So, it is an integer because it is an whole number. Whereas, 11 divided by 4 is equals to 2.75 is not. So, 2.75 is not an integer because it is a decimal. Decimal and fractions are not considered as an integer. So, definition 1 for that divisibility. If a and b are integers with a is not equal to 0, we say that a divides b if there is an integer c such that b is equals to ac, or equivalently, if b divided by a is an integer. When a divides b, we say that a is a factor or divisor of b and that b is a multiple of a. So the notation a, that symbol denotes that a divides b. We write a and that symbol with negation b when a does not divide b. So, we can express a divides b using quantifiers as there exists some number c such that ac is equals to b, where the universe of this course is the set of integers. So we have an example. Determine whether 3 divides 7 and whether 3 divides 12. So we see that 3 divides 7 because 7 divides 3 is not an integer because it results to a decimal or in fraction form. On the other hand, 3 divides 12 because 12 divides 3 is 4, which is whole number and it is an integer. So we have another example. Let n and b positive integers. How many positive integers not exceeding n are divisible by d? So we have the solution. The positive integers divisible by d are all the integers of the form dk, where k is a positive integer. Hence, the number of positive integers divisible by d that do not exceed n equals the number of integers k with 0 lesser than dk, less than or not equal to n, or with 0 less than k less than or not equal to n over d. Therefore, there are n over d positive integers not exceeding n that are divisible by d. So, we have the theorem 1. Let a, b, and c be integers where a is not equal to 0. Then, so we have first, if a divides b and a divides c, then a divides the sum of b plus c. Second, if a divides b, then a divides bc for all integers c. Then lastly, if a divides b and b divides c, then a divides then a divides c. So we have the proof. We will give a direct proof of in theorem 1 first. Suppose that a divides b and a divides c. Then from the definition of divisibility follows that there are integers and t with b equals as and c equals at. Hence, b plus c is equals to as plus at equals a times the sum of s and t. Therefore, a divides b plus c. So, do you have any questions about divisibility and and its properties? Okay, none. So, we will proceed to the division algorithm. So, when an integer is divided by positive integer, there is quotient and a remainder, as the division algorithm shows. So, theorem 2, the division algorithm. So, let a be an integer and b a positive integer. Then there are unique integers q and r with 0 less than or not equal to r less than d, such that a is equals to dq plus r. So, definition 2 for the algorithm. In the equality given in the division algorithm, d is called the divisor, a is called the dividend, q is called the quotient, and r is called the remainder. This notation is used to express the quotient and remainder. Q is equals to A divide D, R equals to A mod D. So, note that both a div D and a mod D for a fixed D are functions on the set of integers. So, furthermore, when A is an integer and D is a positive integer, we have a division D equals to A over D and A mod D equals to A minus D. So, we have an example. So, what are the quotient and remainder when 101 is divided by 11. So we have 101 is equals to 11 times 9 plus 2. So 101 divided by 11 is results to 9, remainder 2. Hence, the quotient when 101 is divided by 11 is 9 is equals to 101 divided by 11, and the remainder is 2 is equals to 101 mod 11. So, do you have any questions about division algorithm? So, this time, watch this video that explains or properly elaborate the divisibility, its properties, and division algorithm.
We're going to begin learning about number theory, and in this lesson we will talk about divisibility. So we're all very familiar with division, but I want to talk about it in a little bit different way. And here we're talking about A divides B, and so again this is divides, and essentially we're asking, does A go into B evenly? And so in this case it's saying A divides B if and only if there exists some number C such that A times C equals B. So let's take a look at a fairly simple example. Does 3 divide 15? And what they're saying here is that 3 times some number needs to equal 15. And of course I know that that number is 5. Notice that C, the value of C, must be a positive integer. Because 5 does belong to the positive integers, then 3 does divide 15. If I look, say, at 3 and 22, does 3 divide 22? Let me make that division a little bit better. And here I would say, does there exist some number C such that this equation is true? And I would get 22 thirds. And while 22 thirds does in fact make the equation true, we know that 22 thirds does not belong to the positive integers, and therefore 3 does not divide 22. So notice the notation is just a nice straight line when we're looking at divides, and then a cross through that if it does not divide. There are 3 basic properties of divisibility we want to talk about. And the first of those is that if A divides B and A divides C, then A divides the sum of B and C. And so before we look at a proof of that, let's just look at it with a specific example. Let's say 3 divides 6 and 3 divides 9. Then we're saying that 3 divides 6 plus 9, or 3 divides 15, and of course we know that 3 divides 15, and so we know in practicality that this does hold to be true. But of course in mathematics we want to show for more than just one set of numbers that this is true, and therefore let's look at a proof. So remember, when you're looking at proofs you want to look at the definition, and we just talked about the definition a moment ago. The definition of division essentially tells me that if A divides B, then that tells me that B is equal to A times some number. And so that's the definition that I'm going to be using. So based on this, I can say there exist 2 values or 2 integers. We'll just call them S and T. Such that, and now I'm going to be using this up here. So I'm saying if A divides B, so I'm saying that B is equal to A times S, and if A divides C, then C is equal to A times T. And again, that is based on the definition of divisibility. From definition of divisibility. So now what? Well, now we have to look at the fact that we're looking at B plus C. So I can say that B plus C is equal to AS plus AT, again, just by substitution. And now looking at this, of course, mathematically, I know that I can factor out the value of A, and the value of A factors out, so I have A times S plus T, and therefore I know, again, because it's written in this format, that B plus C is equal to A times some integer. And I could do a substitution and replace S plus T with some integer, but it really doesn't matter because it's already written in the correct format. Therefore, I have shown that that property is true. The next property says if A divides B, then A divides B times C for all integers C. So again, looking at this practically, we're saying, hey, if 3 divides 15, then 3 divides 15 times any number. So times 2, times 3, times 4, etc. And that's for all C. So again, we can see that this would be true because 3 would divide 30, 3 would divide 45, etc. But as always, we really do want to look at a proof for this. So if we're looking at a proof, we're saying if A divides B, then B equals A, again we'll just use T, for some T. That of course is an integer. And again, where did this come from? This is just based on the definition of divisibility. So therefore, we can say that BC equals C times AT, essentially just multiplying by C on each side. And if I rearrange this, I could say BC is equal to A times CT. And again, now we're just looking at the definition of division. And so by definition, A divides BC, again, because A can be multiplied by that integer CT. For our last property, we're saying if A divides B and B divides C, then A divides C. So sort of a transitive property. So here we're saying, let's say 3 divides 6, and 6 divides 18, then 3 divides 18. So again, yes, we can see this is true. How might we go about proving this? So we know that since A divides B, again, we can look at that definition that says B equals AT. I should have said then. B equals AT for some T that is an integer. Again, based on that definition. Since B divides C, then C equals BS for some S that is an integer. So hopefully you can see where we're going with this. So by substitution, then we can say that C equals, and again, instead of BS, I'm substituting AT. Then C is equal to AT times S. And just like we did on that last one, then we could say, or C equals A times TS. And again, that is just the definition. Therefore, A divides C. And we're all done. This now brings us to the division algorithm. And the division algorithm says let A be an integer and D be a positive integer. Then there exist unique Q and R such that A equals DQ plus R. So essentially what we're saying is D is the divisor, Q is the quotient, and R is the remainder. So for instance, let's say I want, does 4 divide 21? And I want to figure out the quotient, remainder, etc. So in this case, A would be 21 and D would be 4. So we're saying, how could we write 21 in this format? So we're saying 4 times what number plus R? So obviously if we took 4 into 21, it goes in 5 times evenly. So I would write 4 times 5, and then I would add 1, because if I divided 21 divided by 4, I would have a remainder of 1. Now, something that's important to understand is that 0 is going to be less than or equal to R, which is going to be less than whatever I've divided by. Because obviously, if I tried to do this 21 equals 4 times 4, then my remainder would be 5. And 5 is more than what I've divided by, so this would tell me that I didn't do this correctly. And so 0 has to be between, or I'm sorry, R has to be between 0 and D. So let's take a look at a couple of examples here using what we just learned. And remember, what we just learned is A equals DQ plus R. And in this case, of course, the A would be 18 and the D would be 7, because we're saying 7 divides 18. And so what we want to be able to do is we want to say that 18 is equal to 7 times some number plus some remainder, and keeping in mind that R is between 0 and D, and D in this case is 7. So all that means is the remainder has to be between 0 and 7. So 7 times 2 would give us that 14, and 14 plus 4 would give us 18. Now I want to show you how we might write this as a quotient. Oops. Let me try that again. As a quotient and as a remainder. So this is maybe just a little bit different notation, just so you can see, which will be very important to us moving forward. So a quotient can also be written as Q equals A divided by D. And so in this case, we're saying the quotient of 2 is equal to 18 divided by 7. Which makes sense, because when we took 18 divided by 7, 2 was the quotient. In order to write the remainder in the same way, we're saying the remainder equals A mod D. So mod is sort of a new thing for us, but essentially what we're saying is, in a modulo of D, which is a base D number basically, we're saying if we divide A, then our remainder is A mod D. So in this case, we're saying our remainder was 4. 4 is equal to 18 mod 7. And again, that just means if I took 18 divided by 7, my remainder would be 4. Now the reason that I point that out to you is because in our next lesson, we're going to be looking at modular arithmetic, and this concept right here is going to become extremely important to us. Now let's take a look at an example that involves some negative values. So again, we're saying negative 112 is equal to 10 times some number plus some other number. So this one's a little bit different. I could say, okay, 10 goes into 112, that's 11 times. And if I took 10, I'm sorry, that's negative 11 to make it the right sign. 10 times negative 11 is negative 110, and then my remainder is negative 2. But we know that my remainder in this case has to be between 0 and 10, and negative 2 is not between 0 and 10. So instead of writing it in this way, I would have to write negative 112 equals 10 times negative 12, and then now my remainder is going to be positive. So if I took 10 times negative 12, that's negative 120, I would have to add a positive 8. So this would be the correct way to write that. And then, of course, I need to write my quotient, which would be that negative 12, negative 12 equals negative 112 divided by 10, and then my remainder of 8 would be negative 112 mod 10. And then our last one. This one's just a little bit different because, of course, we are dealing with a 0. So essentially we're saying that 0 is equal to 14 times some number plus some number. Now this one actually is a little bit easier than before, so really we're just saying 14 times 0 plus 0. So my quotient is 0, and my remainder is 0, and again I can write it as the quotient of 0 is equal to 0 divided by 14, and that the remainder of 0 equals 0 mod 14.
So, do you have any questions or clarifications, class? None? So, since no questions and clarifications, this time, we will have another activity, group activity, to assess if you really understand the topic. So, you will answer this in 5 minutes. So, the same group, So, after that, just send me your answers through PM, okay? Do you understand, class? Okay. So, answer these 4 questions. Okay, 3 minutes left. Okay, 1 minute. Okay, time is up. Pass your answers. Just PM me your answers. Okay, done? So, class, what have you learned from our lesson today, from our discussion? Okay, anyone? Just click the raising hand button. Yes, Miss Elise? Okay. Solving and proving the properties of divisibility and their theorems. Okay, thank you, Miss Elise. Okay, which part of the activity did you enjoy the most, class? Yes, Miss Kisses. Wow, it's good to hear that you enjoy the groupings or the group activity in solving divisibility and division algorithm. Yes, it's fun and at the same time you learn. So, this time, class, get a sheet of paper and answer this following problem, the problem solving questions individually. Okay, again, individually just send to me your answers through PM. So, I will give you 10 minutes to answer this. Okay, your time starts now. Okay, 5 minutes. 3 minutes. One minute. Okay, time is up. Okay, pass your paper. Send it to me. PM. Okay, done. So, for your assignment class, copy this or just take a screenshot of this. Submit it when ready. Okay? Done? Alright. So, that's all for today, class. Goodbye, everyone. Okay, see you next meeting. You may now leave the meeting.